If 2yz and yz are real number is an eigenvector corresponding to a eigenvalue. It is important here article a eigenvalue, a real eigenvalue, because y and z are unknown here. So if anyhow we got the eigenvalue for this matrix A, suppose I call this matrix A, so it is somehow hard to verify that which one eigenvalue is for corresponding this eigenvector. So first, anyhow you got a relation, or you find the value of y and z, then you can easily tell about their difference. First focus on this matrix 0 1 0 0 0 1 2 minus 4 this 3. First row is of the type 0 0 0 and non-zero value. Second is 1 0 0 0 and non-zero value, and 0 1 0 0 0 and non-zero value, 0 0 1 non-zero value. These are in last non-zero value is known as trace of the matrix. If this is 0, then trace of this matrix is 0. So, and this first entry of the last column is known as determinant. This special type matrix is known as companion matrix. And for a companion matrix, these are comes in a diagonal or in a echelon form. So for a companion matrix, it is easy to write carry equation an plus a1x n minus 1 in general plus a2 x raised to the power n minus 2 plus a3 x raised to the power n minus 3 and so on up to at last an equal to 0. Because this is the matrix 3 by 3, so order of the characteristic equation will be 3. So I am going to write characteristic equation for this matrix. It will be last column is 2 minus 4 3. To write characteristic equation for a companion matrix, we need only last column. This is the value of a1, this is a2 and a3, and negative as in companion matrix. So it will be x raised to the power 3 minus 3 x square plus 4x minus 2 equal to 0. This is trace and this value 2 is determinant. So determinant of this matrix is positive. Now by trial and error x equal to 1, put x equal to 1, 1 minus 3 plus 4 minus 2, 1 4 5 and minus 3 minus 2 0. So 5 minus 5 0. So x equal to 1 is the eigenvalue for this. And by as in statement article used a real eigenvalue, so consider this is eigenvalue corresponding to this vector. So by the definition of eigenvector, AV equal to lambda times V. So A is this and V is 0 0 2. So it will form, because lambda is 1, so AV equal to V. So this is the format of AX equal to B. Means we have to find the solution for this system. So I'm going to write system. It is 0 0 2 1 0 minus 4 0 1 3 and vector v is 2yz equal to same vector 2yz. So write system 2z and it will be 2 plus or minus 4 times z, and this one will be y plus z equal to 2yz. Now by comparison, this is z equal to 1 and 2 minus, by this 2 minus 4z equal to y and z equal to 1. So minus 2 equal to y. So value of y is minus 2 and value of z equal to 1. So we need to find z minus y. Value of z is 1 and value of y is minus 2. So minus minus turns to positive. So 1 plus 2 equal to 3. So value of z minus y is 3.